Let's see how we can record spectra with our system. So our small spectrometer can be run with Logger Pro, which is very convenient. So let's start Logger Pro. Very good. So once we start the program, it recognizes it's connected to a spectrometer and it brings up this interface. The next thing to do is to go to Experiment and choose Change Units, because we're going to use the spectrometer right now in what's called intensity mode, where it just measures intensity as a function of wavelength. That's distinct from the normal modes, which are transmission or absorption. So we'll select intensity, and then we'll look at the other parameters. I'm not sure if you can see them here. The first is the sample time. How much time does it spend acquiring a spectrum? Right now it's set to 30. You may want to set it to 300, and I'm going to set it to 100 right now. The next parameter is called wavelength smoothing. We don't want to do that, so we'll leave that set at 0. And samples to average. You might want to do this, but I'm going to leave samples to average set to 1. The last parameter here is wavelength range, and we'll use the entire range, 380 nanometers to 950 nanometers. Very good, we're done. Now if we enable collect here, it will start collecting data. Let's start by holding up the probe to the room lights. There we are. What you're looking at now is the spectrum of the room lights. Looks kind of funny, doesn't it? There's a sharp peak at around 400 nanometers or 380 nanometers. That's deep in the violet. And then there's a very broad peak centered in the visible spectrum, okay? This funny looking spectrum is typical of LED sources, which have a blue-violet LED that's exciting a fluorescent emitter. So the white light mostly comes from the fluorescent emitter, and then you see blue light from the blue LED. Okay. Now our source is going to be very different. It'll be a discharge lamp. I'm not going to show you the hydrogen lamp. That's the experiment you're going to do. But let's take a look at a mercury lamp. This is exactly the same mercury lamp that you used in the photoelectric effect experiment. So here are the emission lines of the mercury lamp. And you can see that in the visible there are 4 bright lines. And they're in the yellow, the green, the blue, and the violet. And there are actually another line further in the violet that we can't see because it's beyond the range of this spectrometer. But notice the lines are very narrow, corresponding to very well-defined photon energies. All right. Let's go ahead and stop this then. Oh, something I should be careful before we stop. Notice that if the light intensity is very high, as in here, the lines will get clipped, meaning they'll go to the maximum intensity, and then when the camera saturates or overloads, you won't see the actual peaks anymore. We don't want to be in that situation. Instead, make sure the intensity is low enough so that none of the lines are clipped or saturated. Then you'll take data, and when things look the way you want, maybe there, you can stop. And now the data is stored. Of course, you can save the data in a couple of ways. You can save this graph by itself by doing a screenshot. And you can save the data, that is the numerical table of intensities versus wavelengths, by looking in the file menu and doing an export, and export the data as text, or if you prefer as CSV. Text is a tab delimited file, CSV is a comma delimited file, which will open very easily in Excel. You can also open the text file in Excel as well if you like. All right, now let's stop.